What if electrons and protons were not eternal standard parts with fixed properties, but shapes that slowly evolve as the universe itself changes? From school onwards, we are taught that an electron is an electron. A proton is a proton, with mass, charge and spin written in stone, and that the constants in our equations are the settings of reality that never drift. In the energy filament theory, that picture is flipped. A particle is not a tiny pre-made ball but a local structure carved out of an underlying energy sea. And the state of that sea decides how the particle is allowed to exist. The universe is not empty space. It is a medium that can be pulled tight, wrinkled and patterned. And its local tightness, texture density and allowed rhythm all work together to decide how an electron is allowed to coil here and now. In this picture, an electron looks like a clean little filament ring with a circulation of energy running around it and a bundle of straight textures on the outside that we recognize as negative charges. It only stays stable if its shape and internal rhythm fall into a stability window defined by the local tension of the sea. Change the tension and you shift the window. So the same named electron is forced into a slightly different way of coiling and circulating. In a higher tension era of the universe, the same filament would be pulled tighter. Its internal circulation would slow, and its outer textures would become denser and stiffer. In a lower tension era, the coil would relax. The circulation would speed up, and the spacing between allowed energy levels would change. In everyday words, early universe electrons and today's electrons are not exactly the same geometry and rhythm. We just lazily gave them the same name. That raises a sharp question. If particles evolve, why do our lab measurements of electron masses, spectral lines and atomic energies look rock solid over decades? The answer is simple once you notice what your rulers and clocks are made of. Every balance that weighs an electron. Every atomic clock that defines a second. Every spectrometer that marks off wavelengths is itself built out of electrons, protons and atoms shaped by the local tension. When the sea changes, the particles you are measuring change. But so do the particles that make your instruments. You pick up a ruler that has been quietly stretched and use it to measure a rod that has been stretched in the same way. And naturally, you conclude nothing has changed. What we tabulate in textbooks as particle properties are really dimensionless values normalized to the local tension environment. Within one patch of the energy sea, those normalized numbers are extremely stable. So purely local experiments almost never reveal the slow evolution of particle structures on cosmic timescales. To catch that evolution, you need something that can leave its birthplace and stop being edited by the changing sea. The key witness is light. When an electron jumps between energy levels, it does not just move in space. It changes from one closed rhythm to another and hands the difference in rhythm to the energy sea as a traveling disturbance. That disturbance is what we call light. And in this language, a light wave is a stored timing record. A tiny tape that says, at the moment of emission, the electrons here were coiling and beating exactly like this. Once that tape is packed and launched into space, it no longer gets rewritten by every later change in tension along the way. It is more like an old cassette recorded in a different decade, drifting through the cosmos without being silently re-recorded. Billions of years later, that light reaches us, and we read it with today's electrons acting as the playback heads. We then noticed a mismatch. The rhythm encoded in the arriving light does not line up perfectly with the rhythm our local electrons prefer. In spectra, that shows up as a systematic shift of lines towards the red, a slowing of the beat that we usually summarize under the label cosmic redshift. In this framework, the same observation can be reread as a time fingerprint of particle evolution. The light carries the habits of older electrons, while our instruments carry the habits of newer ones. And the gap between the two is the difference between their shapes and rhythms across epochs. From this angle, particles are not timeless Lego bricks. They are living patterns supported by a medium that has its own long history. And the universe's fossil record is written not only in galaxies and clusters, but in the tiny differences between how past and present electrons keep time. Tap follow, share it on New Physics, Clear Universe.